Hey folks, okay, welcome to Professor Smartycorn's tutorial on how to be less confused about atomic mass or average atomic mass. Okay. This number right here in your periodic table. Yes, it sometimes confuses people. Here we go. Alright, so I want to start out by explaining the difference between the atomic symbol notation that we quite often use and the information in the box on your periodic table for an element like potassium. Okay? So they both have the same symbol. This is potassium and this is potassium. And then this bold number in the lower left, that is the atomic number. In each case, that's the same thing for in your periodic table or in this kind of notation. And you know that that's the number of protons. Okay? But up here, in this kind of notation, this is the mass number of this particular atom of potassium. That means it's the number of protons and neutrons that this one particular type of potassium or one particular atom of potassium has. Okay, the number of protons and neutrons. Over here, this number with the decimal, this is the average atomic mass of all potassium isotopes on Earth. It's been weighted, it's a weighted average, weighted by the abundance of those isotopes of potassium. Okay? That's what that is on your periodic table. It's not quite the same thing, and let's explain why. All right, here are three isotopes of potassium, and over here is the average atomic mass of potassium. Okay, so some potassium might be K39, some might be K41, some might be K40. In fact, 93.3% of the potassium in the world is K39. 6.7% of the potassium in the world is K41, and only 0.012% of the potassium in the world is K40. Now, what's different about these isotopes? Well, they're all potassium, okay? They're all this shiny metal. They all have an atomic number of 19 because all these types of potassium have 19 protons. That's what makes them potassium. But they have different numbers of neutrons. K39 has 20 neutrons. K41 has 22 neutrons. K40 has 21 neutrons. These numbers right here, the mass number, this tells you the number of protons plus neutrons. Protons plus neutrons, protons plus neutrons. And it's a different number in each case because each of these isotopes has a different number of neutrons. Now, these percentages, really it's kind of like this. Most of the potassium on Earth is this kind, and then a very small percent is this kind, and an extremely small percentage is this particular isotope. And so if we take the weighted average, lots of K39, quite a small amount of K41, and an incredibly small amount of K40, we calculate a weighted average, we'll end up with this number, 39.0983. That's the weighted average, and the fact that it is closest to K39, that number, 39.0983, is closest to the whole number 39, well, that tells us that, oh, K39 must be the most abundant isotope. This weighs most heavily into the average atomic mass of potassium. Okay, so this average atomic mass is the weighted average of all the masses or mass numbers of all the isotopes of potassium. Now, here's another common mistake I see people make. Let's say we've got a question like this. A species of potassium, meaning a type of isotope of potassium, a species of potassium has 20 neutrons. Write the atomic symbol notation for this species. Here's the right answer, but sometimes I'll see people do this. They'll just stick in the average atomic mass because they think they're just supposed to pull the information from their periodic table. Don't do that. This is an average atomic mass. You're never going to write that number there when you're writing atomic symbol notation. Because you might have another question like this. A species of potassium has 22 neutrons. Write the atomic symbol notation for this species. Well, it would be K19 because it's still potassium, but then it would have a mass number of 41 because it has 19 protons plus 22 neutrons, giving it a mass number of 41. Okay, I hope this has helped you a little bit to understand the difference between mass number and average atomic mass.